Hey y'all, happy Friday. Hope you're doing well. Sorry that I'm not here today, just need to take the day off. Everything is totally fine, so I will see you on Monday. Today, we are going to go back over the rest of that activity from yesterday. So, we're obviously not going to be able to do the competition aspect of it from yesterday, but we are going to work through those problems together. You do need to get page 31 back out. So if you hadn't already, go ahead and grab your binder, grab your calculator, and flip over to page 31. If you were not here yesterday, if you were not here on Thursday, you do need to grab that paper. Please ask your substitute for a copy. Now, I only have enough copies for everybody to have one. I don't print a bunch of extra copies. So if you already had a copy yesterday, make sure you try to find it because I do not have a bunch of extra copies floating around. That being said, once we finish going over the third, fourth, and fifth task cards, then you will have a short little Delta Math assignment. I'm going to trust you because you are wonderful, trustworthy kids, that whenever you do this assignment, you will be fair and honest, and that the results of those assignments are going to be an accurate representation of your understanding of how to do domain and range. What I mean by that is don't cheat. Do not have somebody else do your work for you. Do not copy and paste it into Google or into ChatGPT and have that do it. I need to see what you can do. If you don't know what you're doing, don't cheat. Let me know, okay? I would rather see you give the effort than I would rather see just a 100 with no effort behind it. Okay, with that being said, let's look at page 31. Actually, first, let's fill in your table of contents, and we can just go ahead and put finish average rate of change practice. By the way, this video is posted to your Canvas page, so if at any point you need to go back and see something, don't be afraid to ask your sub to either pause the video or on your own time during Flex sometime next week, you can pull this video back up and pick up any pieces that you missed. Now you need to be on this page, page 31. I am going to be on these pages, these task cards. Now, if you want a closer look at these task cards, that is totally fine. I've got some copies sitting on the center table. Please do not write on them, and please put them back at the end of class. So if you need to see a closer look at those 3, 4, and 5, you are welcome to look at them. Don't write on them, and I don't have enough for everybody. So I'm going to ask that you just do the best you can following along. Make sure you're writing your stuff in these boxes. Okay, without any further ado, let's look at task card 3. Question number 7. The function f of x contains the coordinates 220 and 5200. What is the average rate of change over the interval 2 is less than or equal to x is less than or equal to 5? Okay, this is the interval that we want to find the average rate of change for. So let me make a little table and put 2 and 5 as my x coordinates. Luckily, it already tells me the ordered pair 220 and the ordered pair 5200. So it's just all there ready for me to go. I can find the change in the x values, which is going to be plus 3, and the change in the y values, which is going to be plus 180. And then divide the change in y by change in x, which is 180 divided by 3, which gives me 60. The correct answer is C. Number 8, the function h of t equals negative 4t squared plus 24t gives the height, h in feet, of a soccer ball t seconds after it was kicked. Calculate the average rate of change between t equals 0 and t equals 3. What does your result represent? I am going to go ahead and make a table. It tells me the interval is from 0 to 3. So those are my two x coordinates. And then I am going to use this function and plug in 0 for these t's, and then plug in 3 for the t's. And I'm going to do that in my calculator. So -4 times t squared plus 24t. Let me reload Desmos. There we go. -4 times 0 squared plus 24 times 0 comes out to 0. Then -4 times 3 squared plus 24 times 3. That comes out to 36. From 0 to 3 is plus 3. That should change in x. From 0 to 36 is plus 36. That should change in y. When I divide the change in y by change in x, I get 36 divided by 3, which is 12. So the question is, what does that result represent? The change in the x values, 3, represents a change of 3 seconds. The change in the y values, the output values, represents a change in the height. So, option A says the ball traveled upwards an average of 12 feet per second. Option B says the ball landed 12 feet away in 3 seconds. Option C says the final score of the game was 12-3. Option D says the ball traveled downwards at an average of 12 feet per second. So one option I can go ahead and clearly toss out is the score of the game. It wasn't talking about the score at all. This function is talking about the height of the ball off the ground, not the distance that the ball traveled away from where it was hit. So I can cross out option B. Because this rate of change is positive, the ball is not traveling downward, it's traveling upward. The correct answer is A. The ball traveled upward at an average of 12 feet per second. Okay, number 9. Klaus's family is taking a family road trip. The first bullet point says they drive for 3 hours at an average speed of 55 miles per hour. Then they stop for lunch for 1 hour. They then continue driving for 2 hours at 65 miles per hour, at which point they arrive at their destination. If the function d of t gives the total distance d in miles as a function of t, the time in hours that the family has been traveling, overall, the average rate of change, what is the average rate of change? From 0 to 6. Round your answer to the nearest mile. Okay, first off, what I want to do here is just make a table of what's been happening. So I'm going to do that right here. So if they've not driven for any hours, of course they've not driven any distance. 1 hour into their drive. Well, for the first 3 hours, they're driving at 55 miles per hour. So after 1 hour, they've driven 55 miles. After 2 hours, they've driven 110 miles. And after 3 hours, they've driven 165 miles. Then, for that 4th hour, they stop. So they're still at 165 miles because they've not gone any further for that hour. Then, for the 5th and the 6th hour, they drive at 65 miles per hour. So I'm going to take the 165 I've already driven and add 65. That is 230. And then 230 plus 65 is 295. So I could just say 0 to 6 is plus 6, and 0 to 295 is plus 295. Essentially, that's just asking me to take the change in y divided by change in x, which is 295 over 6, And 295 divided by 6 comes out to 49.16 repeating. Correct answer is C. Even though they weren't driving at the exact same pace every hour for 6 hours, if we average that all the way out, on average, they're driving about 49 miles an hour. On average, they cover 49 miles every hour. Okay. That was task card number 3. Let's flip over to number 4. 3 functions f of x, g of x, and h of x are shown below. Use them to answer 10 through 12. Number 10 says, calculate the average rate of change for f of x over the interval from 0 to 2. So, from 0 to 2 for the function f of x. 0 is right here, which means I'm worried about this point. And 2 is right here, which means I'm talking about this point. Let me just make a table on the graph. When x is 0, y is 1. When x is 2, y is 4. From 0 to 2 is plus 2. And from 1 to 4 is plus 3. If I divide the change in y by change in x, I get 3 divided by 2, which doesn't reduce, but does divide out to 1.5. The correct answer here is B. Number 11 says, do the same thing for the function g of x over the interval from 0 to 2. So 0 is right here, which if I look down, means I'm focused on this point. And then 2 is right here, which if I work my way up, means that I'm focused on that point. I'm going to make another table. When the x-coordinate is 0, the y-coordinate is -1. When the x-coordinate is 2, the y-coordinate is 3. From 0 to 2, the x's go up by 2. From -1 to 3, the y's go up by 4. When I divide the change in y by change in x, I get 4 divided by 2, which is 2. So the answer for number 11 is, I think I'm at a typo. The correct answer is supposed to be A, but that's supposed to be a positive 2. Well, I'm glad that this wasn't the actual competition, because we would have had a problem there, huh? Number 12. Which option correctly ranks each function from least to greatest by their average rate of change over the interval from 0 to 2? Well, I've already done that twice. I've got 1.5 and I've got 2. I just need to do this one more time for the function h of x. So, whenever h is 0, or at 0, the h function has a y value of 4. At 2, the h function is going through the x-axis, so the y value is 0. I'll go ahead and make my xy table. When x is 0, the y value is 4. When x is 2, the y value is 0. From 0 to 2 is plus 2. From 4 to 0 is minus 4. If I divide the change in y by change in x, I get -4 divided by 2, which is -2. So, the function that has the least change, the lowest value, is h of x. So I need an answer choice that has h of x first. That means it's not A and it's not C. After -2, the next highest number is 1.5, which is f of x. So h of x is the lowest. The next up is f of x, and then the highest is 2. It goes from -2 to 1.5 to 2. The correct answer is B. And finally, task card number 5. For the function f of x equals x cubed plus 3, the average rate of change is calculated over the interval 0 is less than or equal to x is less than or equal to, man, that's another typo, m, where m is an integer. For which value of m is the function's average rate of change the greatest? Okay, so what's happening here is it has given me one of the two numbers, 0. And I don't know what the other value is. So first, let me go ahead and in my calculator, say that 0 squared plus 3. If I plug in 0, well, that comes out to 3. Now, what I'm going to do here is copy and paste this 4 times. Because the really only best way we can do this is to guess and check. Then what I'm going to do is plug in 2. I don't know why I wrote down 4. Plug in 2, and then plug in 4, and then 6, and then 8. And get those y values. So 2 squared is 4, and 4 plus 3 is 7. 4 squared is 16, and 16 plus 3 is 19. 6 squared is 36, and 36 plus 3 is 39. And then 8 squared is 64, plus 3 is 67. Everybody's favorite number, yay! What I'm going to do now is find the average rate of change. This goes up 2, and this goes up 4. If I divide the change in y by change in x, 4 divided by 2 is 2. Next one, this goes up 4, this goes up 16. If I divide the change in y by change in x, 16 divided by 4 is 4. This goes up 6. This goes up 36. If I divide the change in y by change in x, 36 divided by 6 is 6. For option D, this goes up by 8. This goes up by 64. The change in y divided by change in x comes out to 64 divided by 8, which is 8. So, weirdly enough, the average rate of change for this particular function matches up with what number we plugged in. That's not always going to be the case, but it is for this special function, which also tells us that the interval where the function's rate of change is greatest will be from 0 to 8. Okay, for number 14, for the function h of t equals negative, man, I made another typo on this. This should have been h of x equals negative x cubed plus x squared plus 2x minus 1, over which interval is the function's average rate of change the greatest. I'm going to have to plug in each of these numbers. So let me make a little table here, 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 and here. At -2, -1, from -1 to 0, from 0 to 1, and from 1 to 2. And then I'm going to take a moment and plug in each of these numbers, except I don't think I want to do it that way either. Desmos is a really powerful tool. And I am going to type in y equals negative x cubed plus x squared plus 2x minus 1. So here's the function that I'm working with. And there's the graph of the function that we're working with. Now, I could use Desmos to find the points on the graph. I could just look at the graph and say what they are. But instead, what I'm going to do is I'm going to click this little gear icon that says Edit List. And then I'm going to click this little table icon right here that says Create Table. And that conveniently gives me, by default, x values between -2 and 2. I could just plug in more x values if I wanted to, like 3 and 4 and 5 and 6 and so on, but I only needed -2 through 2. It's the default numbers. So the y values are 7, -1, -1, 1, and -1. So 7, -1, -2, -7, or excuse me, -2, 7, and -1, -1. 0 has also got a -1. 1 has a y-coordinate of 1. And 2 has a y-coordinate of -1 again. That was a lot quicker than going through and typing in -2 cubed plus -2 squared plus 2 times -2 minus 1. Nobody wants to do that. Then let's find the rate of change. Each of these is going to be a step up by 1. So I'm really just saying, hey, this one goes down 8. That is going to be the rate of change. Since these are all going to be divided by 1, I don't even need to worry about the change in x. We're just looking at the change in y here. So -8, this goes up by 0. -1 to 2 goes up 2. 1 to -1 goes down 2. So I'm comparing -8, 0, -2, and 2. -8, 0, 2, and -2. Since I want to find the one that has the greatest change, the highest number here is +2. Correct answer is C. Number 15, I was feeling particularly evil whenever I wrote this question. Cole has two functions, f of x and g of x. For function f, it is known that f of a equals a, and f of b equals b. See, another typo, man. So, for the first function, it is known that when you plug in a, you get a, and when you plug in b, you get b. For the other function, it is known that when you plug in a, you get b, and when you plug in b, you get a. A and b are positive integers such that b is greater than a. Which of the following statements must be true over the function's rate of change for the intervals a to b? Okay, this is a super conceptual question. Without any numbers attached to it, what were we going to know about the rates of change? So what I'm going to do here is I'm going to make a table for f of x and put an a and b, and a table for g of x and put an a and b. Now when you plug in a, you get a, and when you plug in b, you get b for f of x. For g of x, whenever you plug in a, you get b, and when you plug in b, you get a. That's what all of this is telling me. If f of a equals a, then I've got the order pair AA. If f of b equals b, then I've got the order pair BB, and so on. Again, make sure you catch that this was supposed to be f of b, not f of a. Okay, I also know that a and b are positive integers, so there's no negatives here, and there's no decimals or fractions here. They're just nice, pretty whole numbers like 1, 2, 3, 4, 5. And b is greater than a, so whatever b is, it's the larger number. That's really important to be able to tease out the answer to this question. B is the larger number here. So in this table, when A goes up to B, it grows. This value increases. But for the x's, when it of course goes from A to B going to A, since B is the larger number, this is going down. It's getting smaller. So f of x would have a positive rate of change, and g of x would have a negative rate of change. If b is the larger number, a going to b means it's adding something. I don't know what it is. If b goes to a and b is the larger number, that means it's subtracting something. I don't know what it is. But if it's adding something, the rate of change is positive, and if it's subtracting something, the rate of change is going to be negative. That's going to help me answer this question. F of x has a positive rate of change. G of x has a negative rate of change. And the correct answer here is option C. F of x has a positive rate of change, and G of x has a negative rate of change. That question, whoo Lord, it is not a friendly question. But it's also not hard. You just have to reason out what all of this is telling us. Okay, from here, what I need you to do is put these papers back in your binder, and then I need you to grab your computer and go to Canvas and try the Delta Math assignment. It is linked right here. I don't know why I can't zoom in on Canvas on the app. It is linked right here. Once you finish that Delta Math assignment, it is not long. Once you finish it, you are done for the day. Keep in mind, your remote work, you've had 2 weeks to get it done. Today is the last day I will accept that work. So if you need to get any remote work done, after you finish your Delta Math, that remote work is due at midnight tonight. The Delta Math is due first. It is due by the end of class. So make sure you prioritize that. Once you finish the Delta Math, if you've got any remote work to work on that. If you've got all that done, I suppose you're done for the day. Just make sure you're behaving for your substitute. And again, please be honest about your work. Don't let anybody else do your work. And don't let any other website do your work. I hope y'all have a wonderful rest of your day. Have a wonderful weekend. And I will see you on Monday. Y'all take care. Bye-bye.